right, and so remember, each of you are going to get a ticket for being on today. So we'll go ahead and take care of that. Order.
Okay.
All right. I'm going to start off. If while you're on, if you'll go into biology, go to today's activities, and go to attendance. And we're going to talk through this. So I'm going to put it in student view. We're actually going to talk about this in the notes, but I'm just going to go ahead and, well, I thought I was going to put it in student view. There we go. We're just going to go through it, and you can type in the answers as we go over it. Remember, you have to click on Submit Assignment to get the text box. We're going to talk about independent variables today, so that is going to be the cause. So if you look at this, independent variables usually come after the if. So in this statement, if a student attends after-school tutoring, then they will score higher on their tests than students who do not attend after-school tutoring. So if you look after the if, the independent variables going to be after-school tutoring. So in number one, you're going to put after-school tutoring. And I guess that's two words. Then dependent variable is what you're going to be measuring. So in that is the higher score. So it's going to be the score. Did it say on a test or yeah? So we're going to say test scores because that's measurable. And then you're going to write a hypothesis based on this right here. So if you notice up here, we had an if, the independent variable. So if different amounts of fertilizer are used, then the plant will grow taller than the plants without fertilizer. So since it's talking about different amounts, you may have to pick an amount. So you're going to say if, and let's see, let's put an amount here. If 1 cup of fertilizer is used, then the plant will grow, will have the most growth than plants with less fertilizer. So something like that. And then you're going to click on submit when you're finished. So I'll leave that up for a minute if you need to see it to type it in. And then this is actually what we're going to talk about today. So we'll go through the PowerPoint in just a minute. But normally I was planning on getting that done yesterday, so these questions would have been based on the notes from yesterday. And if you couldn't remember, then you can always open up the PowerPoint from that day that this went along with to get the answers. So and remember, this is not worth any points, but by doing it, and you guys would automatically get 3 points because you've word what I've put here. So that would be like 3 extra credit points. So the attendance assignments are good in that it provides you some extra credit. Is anyone still looking at what I have up here?
No.
Okay, then I'm going to submit just so you can see what happens. When you submit, you get all this little confetti that lets you know it's submitted. And notice up here it says resubmit assignment. So it does allow you to, if you click submit and you didn't, you can click on it and fix it. But these I do close out by tonight. So you have to do them the day of. All right. So let me go back to home here. And before we go any further, I'm going to go back here. Yesterday, we talked a little bit about expected student behaviors. Today, we're looking at 3. If we were here face-to-face, this is what I have. So Maya's already chimed in another class. So Ian and Carter, if you see anything you want to add. So when we're here at school and we enter the classroom, we do have a hand sanitizer dispensed at the door that for you to use. You would need to come prepared. We have a pencil pouch for each of you. Ian and Carter, I'm not sure if you got yours last semester or not. We'll get that taken care of when we're face-to-face. That goes with you to every class in case you need a pencil, a pen, colored pencils, things like that. You've got to have your Chromebook because we're kind of short on loaners, so you want to make sure you bring your Chromebook and charger. If you don't have supplies, I circled request permission to get them if you left them in another room. And also, if you don't remember where you left them, ask to borrow some for the day. We added over here also in coming in to go to your assigned area, especially now when you have to be the 6 feet apart. And then how to leave the classroom is to ask at appropriate time. But we want to also do this politely, which politely is under the behaviors. So guys, can you think of anything we should change here or add? I guess not. Huh? You're good?
Yeah, we good. I'm listening. Okay. I promise. I just got other people around.
Okay. Well, I just want input for this. So
no, you good. I'm listening and I'm understanding. That's it.
Okay. So what we're going to do today then is, we're not in physical science, we're in biology. We are going back to today's activities, and I'm going to talk through the notes. Now, you have the option to fill these in as we do them, or you can fill them in later, but this is an easy 20 points for you. So if you click here, you have the notes here at the top that I'm going to talk through, and then you can fill in. Open the assignment page from Canvas and open the template. Is this what you were getting, Maya?
Yeah.
I've never had that happen before. So what do I do here? Move. Give me a minute to figure out what's going on. Ian and Carter, were you getting a message when you got on that page?
Yeah, I actually got it earlier when I got on with you.
Okay. That's what well, I don't know what's going on here. Go to assignments. So let me go to assignments. I don't understand. It's never done this before.
It's working now.
Is it working now?
Yeah.
Okay, so whatever I clicked on worked. I guess I just had to click up there on template, and I never had to do that. Is it, if you refresh, Ian, does it work for you now? Or Carter? I'm not sure which one I'm talking to.
No, I'm looking. Hold on. It's loading right now.
Okay. I may have just had to click on the template, but I've never had to do that before.
Yeah, it's working for me now.
Okay. Good. So you guys can fill in as we go along. Remember, you just get the text box and it's fill in the blank. But this is one way to build up some easy points for the class. If you notice, though, on the due date or how long it's open to February 12th. But don't wait till February 12th to get all the assignments in. But after February 12th, you won't be able to access it. So if you happen to miss and forget to do it, you have some time to get it turned in. But if you can type on it as we do it, and then you can submit it, that would be great. So I'll go back in student view so you can see, and most of you should be familiar with Kami now and submitting. It should be, when you're done, you'll submit right up here. And it allows you to resubmit. Sometimes it may take your answers away on a resubmit, and sometimes it keeps them. I've had it happen both ways. All right, so we're going to, and if you've had me for physical science in the past, this is kind of almost identical information. But basically, science is how we know the world. It's based on observations. We do experiments. We draw inferences. We want empirical evidence. Well, it can't be based on empirical evidence. We've got to have data to back it up. We've got to have some type of data. And a lot of people are publishing stuff that don't have the accurate or reliable data, so it gets people confused. So we talk about facts, and these are objective, so that we can verify them. So if I have a thermometer and I boil water, I'm going to notice that it's going to start producing the bubbles when the thermometer reaches 100 degrees Celsius. It's always going to happen at our elevation, where we're at. It changes a little bit the higher elevation you get, but it's still going to be very close to 100. Principle is just something that's repeated on experimental observation. So it's an observation that's been repeated through experiment, and it's describing some aspect of the world, like greenhouse effect. We know that the more carbon that we have in the atmosphere, the warmer is causing that greenhouse effect. Law, these are sort of the how. It's describing, it's not explaining. And these are usually accepted as facts. And so we have one from physical science, Newton's laws of motion. We have Boyle's gas laws, as well as from chemistry, law of conservation of mass. Those are some examples. Theory is going to explain a phenomena, so it's going to be based on facts. It's going to have evidence based on from the research. It's trying to explain why, and typically these never become a fact or a law. You've got to have a lot of evidence for that to actually transfer over. So even though the cell theory that we're going to learn about in biology, we know that happens, they've never made it kind of a law. It's state of theory, because it's kind of explaining why, and it's not describing patterns. Well, we shall see. There we go. Computer's slow. So science is all about experimenting. And so the scientific method, here are sort of the steps in it that you should be familiar with. It tends to start with an observation that leads to a question. You are going to do some type of background research. You're going to make a hypothesis. You're going to test it with an experiment. You're going to analyze your data, and then you're going to draw conclusions. So we're going to run through these real quick. So questions come from your observations. So you're going to do, observation is going to be something that typically uses your 5 senses. It's not an opinion, so it has to be objective. So this morning, we all noticed when we looked outside, the ground was wet. And you probably, when I walked outside, I knew the reason. It was raining. If we couldn't see the rain falling from the sky, we would have made an inference that said it rained last night. So that is sort of a guess about what caused it. You make inferences from a single observation. So it rained. So if it wasn't raining this morning, when you saw the ground was wet, you could infer that it had rained. We probably were very disappointed that it wasn't snow. This picture, and I may have used it in a class that you've had with me before. Everybody chuckles at this picture. But you can make observations and inferences here. So you could say that there are 5 people in this picture. You could say that there is a man, and a little more difficult to tell. I think there is at least 2 boys and 2 girls, but we, in today's world, can't really, it's hard to tell that from this picture. We could say that they're all wearing short sleeve shirts. 3 of them have shorts on, 1 has pants on. You could describe the color and so forth. Those would be observations. Inferences would be, it appears that they've been to some type of outing where they've got prizes, because it looks like there's a cup and something in one of them's hand. There's something else in another one's hand. We could say that the little boy in the front with the red shorts, something's got his attention that's going on the street based on how he's looking. So those are inferences. We could infer that they're in a city because we can see the parking meter. We can see buildings behind them. So that gives you an idea of observation and inference there. So then you ask questions. So your observations that you make, what we just made, most of them were qualitative because they were descriptive. They used words. I did have one quantitative when I said the number of people. So when you use number, it's quantitative. So those are pretty simple there. Here's another way of making inferences and observations. So we see that there is one girl, or we can make qualitative and quantitative descriptions. One girl, I could count the cookies over there, and or what we assume are cookies, some item that they baked. We could have a number for the cookies. I see 1 spatula there. Those would be quantitative. Qualitative would be, there's a girl. She has blonde hair. She has a blue shirt. She's holding a cookie. Those would be observations that way. The cookies are on a black countertop. They're on a cooling rack. Those would be qualitative observations. There may be a space in your notes where you are to jot those down. I can't remember. So you've got to be precise when you're doing quantitative. Precise is very specific. How close is your measurements to each other? So if I measured the length of a table here in the classroom and each of you measured the length, how close we got to each other's measurement is precise. Accurate would be how close your measurement is to the accepted value. So when these desks or tables were purchased, they told you the length of them. How close is your measurement to that accepted value? That's accurate. You want to always give the most specific reading, so you tend to do at least 1 decimal place when measuring. So here's sort of dartboards that help visualize this. Precise and accurate means that you've hit the bullseye every time. And the dots are kind of off of each other a little bit so you can see them. Precise but not accurate, we've hit the same mark every time, but it's not the bullseye. Here is accurate. It's all in the bullseye circle, but it's not the same spot, so it's not precise. And this is neither. So that gives you some examples. Background research, this is just finding out what's already been done. If we were writing a report, we would have observations, we would have questions, then we would come up with research to come up with our purpose. So you've got to find out what's already been done on your topic and then come up with a statement. It's like your objective based on your question. Your hypothesis is a testable prediction. It's a cause and effect, and this is how we format it. If the independent variable, which is the cause, then the dependent variable, which is the effect. So an if-then statement is what we call it. Independent variable is what we're purposely changing. So that's going to be the cause. It's going to always be on your x-axis of a graph. And it'll be different between experimental groups. So I will just use the vaccine, that's COVID vaccine, since that's out in the news. When they were testing for vaccines, they would have a experimental group and they would have a control group. The experimental group got the actual vaccine they're testing. The control group got a shot, but it wouldn't contain the vaccine. They may have had different experimental groups, and those groups may have been based on age, maybe want to have the same number of gender, males and females in each group, and so forth. Maybe it was the different dosage amounts in each experimental group, but the only thing that is different in the experiment is whatever they're testing. So if you were testing 3 different vaccines, then each experimental group got one of the different vaccines. The control group gets nothing. It's called the placebo group. Dependent variable is what's going to change in response. It's what's measurable. It's what's on the y-axis. It's the data you're collecting. I can't remember if we did the running experiment, but there was a running experiment where if you were Gatorade, it's supposed to cause you to run faster. So the dependent variable would be your speed. You're going to, when testing, you need materials. You've got to know specific amounts. And a lot of times when we do these, we have it pre-set up for you with all of the materials and everything. Brands are important. And how to write it. You do every step that you take so that someone can repeat it. Experimental group is the ones being tested. They get the independent variable. So this would be the group with the Gatorade if we're testing for Gatorade. Control group, these would be what we call the normal group. They wouldn't get what's being tested, so maybe they get water or they get nothing to drink, but they would need to drink something, so probably water. Constants would be things that you would keep the same or consistent between the two groups. So if we're dealing with running, we would want to keep the age the same training. We don't want non-runners and runners who have trained to be together. The only difference you want is that independent variable. So here's an example here. And then you want to make sure your experiment is repeatable. You don't want to make any mistakes. And results, you tend to put in a data table and turn that data table into a graph. And when you analyze it, you're only referring to what the data shows. What is the data shows? Your claim is the hypothesis, your evidence is your data, and your analysis is your reasoning. So what is it that the data is showing? Is it showing that your claim is proven correct? And we don't say right or wrong. We say proven or disproven, I believe, is how they want it. And so, or rejected, supported or rejected. So it's, you know, your hypothesis was supported or it was rejected by the data. And just because it's rejected doesn't mean it failed. So you have to have that statement in there. And always talk about a real world situation. So that was just a brief overview of these notes here. They went straight through that. And you don't have to worry about the summary at the end. So that is just we fill it in, click submit, real simple easy points, just a little bit time consuming. Notice about 30 minutes. It might be less if you're not listening to me talk. There's an Edpuzzle video. I hope I have it set up. If you haven't done Edpuzzle videos before, it's a video. As you watch it, it asks you questions. Before you answer it, you can rewatch the segment. And then we have a practice here. And with this, you are going, here you're writing hypothesis, or first you're identifying variables. So if you look at the example, if two plants are placed in different amounts of sunlight, the plant placed in more sunlight will grow more. Always look for the if, and that's going to be your independent variable, what comes after it, different amounts of sunlight. Dependent variable is always going to come after the then, and it's going to be what is you measuring. So in this case, growth. So in 1 through 4, you are just identifying independent and dependent variables. And then the second part here, you're writing it. So you're going to start if the amount of caffeine. So you might want to say if the amount of caffeine is high, then the heart rate of children will increase or decrease. So you're going to write 4 hypotheses there. Here, you are going to read the scenario, identify the independent variable, dependent variable, hypothesis, control group, experimental group, and constants. Remember, control group is the normal group. Experimental group has the independent variable. Constants, look for the word same. So you have a few of those when you're done, and then submit. All right, so any questions?
No, ma'am.
But you got to actually do at least the notes in the video if you're going to pick and choose. I really would like you to do everything, but the notes in the video are the simplest. Okay.
All right.
You will have some questions. We're going to have a little quiz Monday or Tuesday that will have information from this presentation. Where you have to pick out independent variables and, hypotheses and stuff, as well as some questions from the class syllabus. So make sure you do look at that file.
Yes, ma'am.
Oh, I keep on the wrong one. I don't have next week's stuff where you can preview it, but we meet again Monday. So next week we'll have Google Meets Monday through Thursday. Friday is an independent work day, so there'll be assignments. There'll be an attendance that you do. You'll have to do the assignment that's on there. You will, for that Friday, and then if all goes well, on the 19th, we'll come back. So next week, there'll just be 4 days of required Google Meets. Same time, 10:30. Okay. For my class. All right, so any questions?
No.
All right. So I hope later today I can look and see that you've gotten started, and I can grade some things and get you some grades in.
All right.
All right. Well, have a good day.
You too.
Bye. Bye.